using statistical analysis in forecasting probability of success for retirement planning. I've been thinking about this a lot lately, and when I get back from taking Pablo, who just did his duty as a dog, which I police up because I'm a good citizen of America, even though I'm sans mask. I've been thinking about this a lot, especially when it comes to the coronavirus stuff. All right, so we have this need, I don't know what it is. When it comes to numbers, people irrationally attribute science to this stuff as if it's scientific, or they irrationally avoid the numbers if it doesn't suit their narrative. Let me share with you when it comes to coronavirus, first and foremost. The likelihood of you getting the coronavirus is no big deal. It's just not a big deal. It's just not. You getting the coronavirus and dying is almost nil. It really is. Now, the argument, of course, against that is, well, people die, more people died in Vietnam. Well, we can make a case for who those people were who died, and they're most likely not you. All right, now, you can also make a case similar that the likelihood of you getting a peanut allergy to kill you at anaphylactic shock and dying from a peanut allergy is not high either. But if you have peanut allergies, you doggone better be careful. That makes sense. You should be careful if you have peanut allergies from peanuts. That is a fact. My kids need to be doggone careful. Your kids do not need to be. Why? Because they don't have peanut allergies. Thus, if you're not at risk of A, dying from the virus, B, getting it at all, don't worry about it, man. But we don't shut down the whole world because you have peanut allergies and say no peanuts can be delivered anymore. It doesn't make sense. We say that people who are allergic need to take precautions. The people at risk of coronavirus need to take precautions. Everybody else just go on to your life. But I could get sick. Yeah, well, welcome to the world of flus. Welcome to the world of viruses. You could. Welcome to the world of allergies. You could get sick. If you're at risk, you got to do what you got to do to stay safe. Everybody else, though, freaking eat peanut butter all day long, as I do. All right, so but people don't want to hear that. They don't want to hear that. They say, I don't want to get the virus. Why? Because I don't know why. I literally, to this day, I don't know why people are so scared of it. It's the weirdest thing to me in the world. I just don't understand it. It's rational when it comes to numbers. All right, now, let's use the same thing for retirement planning. It's almost the exact opposite. People refuse to listen to the numbers for statistical analysis on the coronavirus, and yet they freaking take heed of retirement planning analysis, statistical probabilities, as if it's freaking sacrosanct. It's crazy. And again, I'm going to show this to you what I'm talking about when I get down in front of my computer later on this morning. All right, so first and foremost, Monte Carlo scenarios are using a mean rate of return with a standard deviation. That's what Monte Carlo scenarios do. All right, what is it based on? Well, it could be based on anything. I mean, my numbers are based on the VCMM, Vanguard Capital Markets model, plus what Jeremy Siegel would say, plus what Schiller say, and using my own brain up here, I devise a number of a rate of return I expect stocks to get going forward. All right, that's a probability. It doesn't mean anything. It's simply a projection that I am using. And I have a standard deviation based on historical stocks. That's what I use. So I think my standard deviation on 100% stocks is like 18% or something like that. Standard deviation on international stocks is like 25, something like that. All right, so that's what we take first and foremost. All right, and that's based on historical, the evidence of historical returns, historical ways we got those returns, and historical standard deviations. All right, that's fine. But let's just say I'm using, for simplicity, a 5% mean, that's the average rate of return, and I have, for simplicity, this 10% standard deviation. That means 68% of the time in any given year, you'll have between negative 5% and positive 15% rate of return. I think it's 95% of the time, you'll have between negative 15% rate of return and positive 25%. And 99.8% of the time, you'll have between negative 25 and positive 35% in this model. The old model thing. Is that, what's the probability of this actually playing out in real life? The answer is zero, or well, it's not quite zero. It's literally minute. Why? Because these are based on historical numbers using projections going forward based on just simple analysis that human beings who don't know the future are using to give you a sense of, could this happen? And the answer is it could happen. Not very likely, but it could. I know this isn't making sense, but when I show you, when I get in front of my computer, I want you to understand it. The facts are, using historical evidence of US going back to 1926 is not a big enough sample size to predict the future of what you specifically could get in your performance. And using historical evidence, even with international markets going back 40 years, is not either. That is a sample size too small. Now, what else you do? I don't know. But this is where common sense has to dictate. What else you do? Because we're saying essentially, oh, Mrs. Smith, you got a 90% probability of success. Well, what does that mean? That means if the previous events occur, which allows us to put together probabilities based on previous history, you will 90% of the time, you have a probability of success. But those numbers won't come to fruition. There's no way. And I'm just telling you, think about all the changes that happen in the course of human history. Just the idea that these things from the past are going to extrapolate themselves into the future, it's crazy to me. It's crazy. So people sit there and say, I only have a 65% probability of success, thus I can't retire. And I'm like, that is if these numbers show up today going forward, that is true. But it's not. The likelihood of that happening is so minute. Why would you sit there and bang your head against the table and say to yourself, this can't happen because those numbers are there? It doesn't make sense. You're using past data, which cannot be, it's not God's spoken word as to the future first and foremost. We don't know. Secondly, we know. I would highly, highly suspect that the past results will not be extrapolated to the future. That means it could be better, it means it could be worse, we don't know. Thirdly, the very next day, what you're seeing today is going to change based on what happened yesterday. The very next day, your probability of success will change. Lastly, 2 years goes by. Two of those we're using a bell curve in Monte Carlo, it's a Gaussian approach, if that makes sense. Again, it's 65 or 68, 95, 99.8. All right. So we fast forward a year. All right. So that's 1 year behind us now. If the negative side of that bell curve, so you got your mean in the middle, if the stuff on the left of that bell curve didn't come to fruition, well, that's that's one less risk year we have to take in terms of saying, can I retire? So if you retire, well, let's just say you have a 65% probability of success. That assumes a lot of bad things going on the left side of that bell curve. If that doesn't happen in year one, what does that do? It inherently increases your probability of success as long as you do your time frame 1 year less. If it doesn't happen in year 1 and 2, what does that do? It greatly increases the probability of success as long as you take your life expectancy down by 2 years, because now you have 2 years that are of life that's behind you. So to sit there and say, oh, I can't retire because I got 65% probability of success. Well, that assumes that you have these, A, that your numbers going in is correct. And I'm telling you, man, I think that's a huge assumption to make. And B, it assumes that the first year, 2, 3 are going to be bad. And if they're not nearly as bad as what we're using in our probability of success, that changes everything. And then you've been working for nothing because you could have retired. Anyway, I'll show you more what I'm talking about in this regard because I think it's incredibly important. You just can't get so caught up in statistical probabilities to say, because what happens if, literally, what happens if everything changes? You had 100% probability of success, which a lot of people says you are almost a guarantee that you can't run out of money in retirement. Well, that's based on whatever inputs we use. What happens if everything changes? We have a Bolshevik takeover. We have an asteroid. We have a global solar minimum. All these things change. What happens to what was 100% probability of success? Well, it's all gone. What does that mean? Does that mean you should have never retired? Because even though you have 100% probability of success, something could happen, and that changes it to 50? No. Well, the same thing happens if you have a 65% probability of success. What happens if things go better? You should have kept working because you only had a 65% probability of success, but now you got better rates of return, all that stuff. One thing, if you have a negative event that happens, who had a 100% probability of success is just as doomed as those who had 65% probability of success. If you had positive things that happen, those who had 100% of probability of success probably should have retired, and those who had 65% probability of success now have a higher probability of success. Anyway, let me get in front of the computer. I'll show this to you because I think a visual will be better. All right, we'll see you.